Hello everyone, Mr. Newman here, and today we're going to learn or relearn about polynomial division. I want to build some intuition for this, so before we get started on the polynomial division, which looks awful and tricky, let's flash back to 4th grade. You guys remember before you had calculators, when your teacher asked you to do 927 divided by 4, or something like it, you did long division. Now, I'm going to show you a slightly different version of long division that you probably remember or learned, but you should see what the difference is. So what I'm doing is I'm looking for 4 going into 9. How many times does 4 go into 9? Well, you probably did that and said, hey, there's 2. I want to look at it as how many times does 4 go into 900? That's 200 times, okay? So I want to take that away because I want to leave behind an amount that I need to figure out what else the 4 can go into. So 200 times 4 is 800. Let's subtract those. You get 127. Now, how many times does 4 go into 120? Well, that, you might say 4 goes into 12 3 times, so 4 goes into 120 30 times. And sure enough, yep, we got 120 down there because 30 times 4 is 120. Then you subtract that again, and you get 7. And we need to do, all right, how many times does 4 go into 7? It goes in 1 time, and when you subtract that, you get 3, and we call that a remainder. So you'd say, all right, well, 200 plus 30 plus 1, and you might have just written them out side by side when you learned, is 231 with a remainder of 3. What this actually means is 231 and 3/4, or 231 plus 3/4. That 4th comes from we're dividing by 4. So we're going to do the same thing, but we're going to do it with polynomials. And notice the number on top is the number that goes inside. So our polynomial that we're going to divide is 6x cubed minus 19x squared plus 16x minus 4. And we're going to do x minus 2 is going to be what we divide by. What we want to look at is anytime we're doing this, I always want to look at the very first term on the outside and that first thing that we need to eliminate right there. How many times does x go into 6x cubed? Well, it goes 6x squared times. The reason is because if you take 6x squared and you multiply it by x minus 2, you're going to get 6x cubed minus 12x squared. And notice where I wrote this. This term right here, I wrote offset to the right a little bit. I actually wrote it over one term just so it lines up, and when we multiply, these line up real nicely right here, okay? So no need to draw those arrows in that line, but I just want you to see where I'm writing it so it kind of keeps track of where I am, okay? So I did multiply 6x squared times everything out here on the outside, and that's how I got this next row to see what do I need to take away and how much polynomial is left. So next thing you did with you notice here you subtracted because we're taking away whatever's left over. And when we subtract, be very, very careful with the negatives. This is the part on these that always trips students up. If you make any mistake, it's probably going to be with the negatives. Always double check as you're doing it. So negative 19 minus negative 12 is kind of like plus 12 becomes negative 7x squared. I'm going to pull this 16x down. And the next one I'm looking at is, all right, how many times does x go into negative 7x squared? It goes in negative 7x times. Because if you have negative 7x and you multiply that by x minus 2, you're going to get out negative 7x squared as the first term. I want to multiply the negative 7x and negative 2 to get positive 14x. And once again, we're going to subtract that out. Again, be very careful with your negatives. We get 2x. And let's pull down the 4 and the negative 4. Lastly, how many times does x go into 2x? It goes in twice, so we're going to say plus 2. And when I multiply that out, we write that down here, 2x minus 4. When we subtract that, we get a 0. And this 0 shows us that there's no remainder. Right here in our example, we had a remainder. We're going to do some that have remainders in a moment. But this 0 is important because not only does it show it's that we don't have a remainder. It also shows that this x minus 2 is a factor of this big polynomial here, and that will be important later when we're trying to prove what's a factor. All right, so our answer is, this right here. That polynomial 6x squared minus 7x plus 2 is equal to this fraction. Let's tackle it a different way. Sometimes you'll see the division symbol, sometimes you'll see the fraction like on the last one. Same difference, but one thing that's importantly differently here is you notice how there's no cubic term. We need to account for that when we're doing long division. It's just much in the same way as if you, instead of, on this previous slide, instead of 927, if we divided by, I don't know, 9,027, we would have to take care and think about, okay, what happens to that 0 there? So, in the same way, what we're going to do is we're going to write this out, but instead of writing it exactly as it is there, we need to put our x cubed term. Well, what's the coefficient of x cubed? If it's not there, the coefficient is 0. So we're just going to put 0x cubed. And I wrote all of the rest. This right here is exactly what we started with. I'm just including a 0x cubed to help as a placeholder. And you'll see it'll be very important very soon. All right, x plus 3 is on the outside because that's what we're dividing by. And let's begin. So how many times does x go into x to the 4th power? It goes x cubed times. So we're going to write this out. I'm not going to write out what I'm multiplying, but notice each time I'm taking this number I just got on top and I'm multiplying by the thing we're dividing by just to see how much we need to remove from the polynomial to see what's left over. So let's subtract that. And you notice we got a 3x cubed there, so we need to make sure that 0 is there to help us figure out, oh, we have a negative 3x cubed term here now. So how many times does x go into negative 3x cubed? Well, let's pull that down. It goes negative 3x squared times, because negative 3x squared times x is negative 3x cubed. All right, we multiply those out. Once again, I'm going to subtract. Here again, you be very, very careful with your negatives. This is where it trips a lot of people up. Negative 10 minus negative 9, that's like negative 10 plus 9, is negative 1x squared. All right, let's pull down the negative 2x again. And here we're looking, all right, how many times does x go into negative x squared? It goes negative x times. And we get, when we multiply it out, that right there, subtract it, and we get x. So as I take down the x plus 4, we got a problem. Our remainder, because x goes into x one time, our remainder is not 0, it's 1. So what we do with this remainder now, we're going to put this at the very end as a fraction on top of what we're dividing by. If you have a remainder of, before we had 3/4, that's because we had a remainder of 3 and we're dividing by 4. Now we have a remainder of 1 and we're dividing by x plus 3, so we're going to just make it as a fraction, divided by x plus 3. All right, always a good idea to check your work. On these, how in the world do you check your work? It's especially important here because of how often we mess up with negatives. This right here is our polynomial. That's our result. So we're just going to multiply that back by the x plus 3 and see what happens. I'm going to write this out and I'll show you a little shortcut you can do. First of all, did you know that when you're distributing, you can just distribute to just one term? You just have to be careful how you write it. So I'm going to leave everything the same, but I'm just going to multiply by that one term. When you multiply x plus 3 times 1 over x plus 3, you get 1. So right here, what I'm going to do is I'm going to go ahead and multiply. Remember this plus 1, that's going to be important at the end here, okay? I'm going to multiply this binomial times this, not trinomial, quaternomial maybe? I don't know. Quadnomial. Anyway, 4 different numbers, and I like the Punnett square for that. So, yep, we're just multiplying them out. Use the box method. And notice what happens. X to the 4th is how we start. Then these two add up to 0. And I really like doing this because what you start seeing is, I don't know if you guys notice, as you start writing these down, a lot of these numbers show up as numbers that we had from before. Okay? You see all those connections up here? I'm just drawing these circles because it's fun. All right. See all those? Those numbers are the reverse of what we just did in division. So this is where the division came from. All right. So negative 3x cubed plus 3x cubed is 0. Next, negative 9x squared minus x squared. That's negative 10x squared. And then we've got negative 3x plus x. That is, whoops, typo. I guess it's a righto. Negative 2x. And then plus 3 at the end. And wait a second, this is all correct except for that plus 4. Well, do you remember we had plus 1 at the end there? That plus 1 is what makes it plus 4. So this right here is exactly what we started with, and that's how we check our work. All right, next up, check. Next up, I want you to try some of this one on your own. I'm going to get you started. Notice we don't have an x squared or an x term, so we need to include those, both 0x squared and 0x, as terms in the middle. Go ahead and try this on your own. I'll show you how to do it in a moment. All right, how'd you do? Well, here's what I'm going to fly through this rather quickly because this video is already getting very long. Notice I'm pulling down the zeros and I'm just multiplying. It's all color-coded, so if you get stuck, I do like doing these in color. The problem is often colored pencils are harder to erase, and it's best to do this work in pencil because you often need to erase. All right, we got all the way down here. We are, the remainder is 0, so that means we got exactly 0 out. Now, this right here is what you're going to multiply to check your work. Again, I'm going to leave that to you. That way this video can be a little bit shorter. On this last one, let me be the first to just say yuck. Notice one of the problems is they weren't kind to us. They put all the exponents out of order. So what I'm going to do is I'm going to rearrange them and have the highest degree term first. So first with the denominator, x squared plus 2x minus 3. And inside, I'm going to rearrange it. So 2x to the 4th is first, all the way down to minus 2 is last. All right, this makes it a little better. Now, don't be too worried. The nice thing about this here, we're dividing by trinomial now. The nice thing is that a lot of this stuff gets eliminated really quickly, and you'll see what I mean in a moment. So in some ways, dividing by trinomials is nicer. Again, all I'm going to focus on is this first term here and here. How many times does x squared go into 2x to the 4th? Well, it goes 2x squared times. Now notice how I wrote it 2 terms over because we have a trinomial that we're dividing by, and when I multiply this out, notice it's going to fill up all the way out to the beginning. So 2x squared, because x squared times 2x squared is 2x to the 4th. We multiply all of that out and we get this. Let's subtract that and we get x squared. So look at that. We eliminated those first 2 terms very quickly, and because I have a trinomial, I'm going to pull down 2 terms at the end, so I have another trinomial I'm comparing it to. All right, so how many times does x squared go into x squared? Well, it goes 1 time. Let's multiply that out. It almost has no remainders, but we do have a remainder, and this is good that this happened because I want to show you guys what this looks like at the end. We're going to say a remainder of x plus 1, but really the best way to write it is to write 2x squared plus 1 plus a fraction bar. The numerator is our remainder, x plus 1, and the denominator is what we divided by, x squared plus 2x plus 3. So this is the complete answer for this problem. All right, let's hop on down to the bottom here. What I'm going to do is I want to show that these are factors. We do that by dividing them and showing that the remainder is 0. And what's nice is once you've done one of them, you don't have to divide the whole thing again. You can use what you've got as left over. So let's go ahead and divide this. I'm going to fly through these steps rather quickly. And notice the numbers start to get out of control, but with that 27 there, they come back in. I always get worried when the numbers get too big. It's almost like I feel like I made a mistake. Well, so 8 plus 18x, negative 36, well, phew, that gets down to 9x, and good thing that's 18 because that makes the remainder 0. All right, now, instead of using, we just did this one, right? Check. Instead of using this whole thing for the next one, let's not use that. Let's use what we got out. Because if we divided by a factor, this new polynomial is another factor of our original function. So we can use that and divide by that instead. So I'm going to write that in here. We're going to divide by x plus 3 this time. And it's a bit easier than having to do the whole big polynomial. Let's write our steps out. They're color-coded for you, and we get 3x plus 9. That looks nice because when you add 3, that has a remainder of 0. Now, last thing they asked us to do is to find the remaining factors. I've got this trinomial, and this is just a matter of factoring trinomials at this point. So I'm going to test out, I think 2x and x will have to be the first terms in the two binomials. And if you just play around with it, try something, I think that will work right there because 3 plus 2 is 5 for the middle term. And those are our remaining factors, this one and this one. All right, lastly, I'm going to give you guys a hint here. One thing is that because all of these numbers, all the coefficients are rational, 2, -1, -10, and 5, because they're all rational, I know that if the square root of 5, x plus root 5 is a factor, I know the conjugate pair of that is also a factor. Now, if you think back, conjugate pairs, that's where instead of adding, you subtract, or instead of subtracting, you add a square root. The reason for this is if you can think of the quadratic formula, opposite b plus or minus the square root of b squared minus 4ac all over 2a. This right here, this plus or minus, anytime you have a square root in the answer, there's going to be two solutions, a positive and a negative solution. So all of that to say, I'm going to cheat just a second and think about, all right, well, if that's also a solution, let's multiply these two together and see what we get. Well, you get x squared minus 5. You can use a Punnett square to figure that out, but that's what you get. So when I'm dividing, I have two choices. I could divide by this, or I could divide by the x squared minus 5. Now, I'm not going to actually divide by the x squared minus 5 because it's missing that middle term. And so what we'd have to do some fancy footwork where we're actually dividing by x squared plus 0x minus 5, kind of like what we did before. And that might just get a little messy. But so let's divide by the 2x minus 1 here. And when we divide by that, we get x squared. We subtract that out. Oh, that's 0. So one nice thing is if this ever happens, just like before where, hey, I've got a binomial, or I had a trinomial and I wanted to pull down two things, because that's 0, I'm going to go ahead and pull down two terms so that I can use the binomial again. And that way, when we do -5, we get 0 coming out at the end. Well, wait a second. Look, we just got x squared minus 5. That's the same as what we solved before. So I don't need to prove this other one is a root by dividing. I just did by showing it multiplies to get what we got as our result. So because these two are the same, and because this is a, let's see here, this x minus 5, or sorry, because x plus 5 is a factor of x squared minus 5, I showed that right here by multiplying it, I don't need to divide it out again, which would be pretty messy if you think about, let's try doing long division with a square root. All right, thank you for watching. Come to class ready to do lots of example and practice problems, and I hope you have a good day.